So what is the cumulative frequency curve and how, for what purpose it is used? So cumulative frequency curve is used to represent the continuous data. It is plotted between cumulative frequency and the boundary of the class intervals. Cumulative freq On the behalf of cumulative frequencies, cumulative frequency curve is also of two types. The type of cumulative frequencies are less than type and greater than type. The greater than type cumulative frequencies is obtained by adding frequencies one by one from the last class interval towards first class interval. And less than type cumulative frequencies are obtained by adding frequencies one by one from first class interval towards last class interval. In cumulative frequency curve, which are also called as ogives, we plot less than type cumulative frequency against the upper limit of the class interval and greater than type cumulative frequency against the lower limit of the class interval. What are the importance of less than type and greater than type cumulative frequencies? So that can be obtained with the help of this example, which I have considered. Here less than type cumulative frequencies, you can see that first less than type cumulative frequency is equal to frequency of the class interval. Then next one is obtained by adding the frequency of the current class interval to the previous, that is 19 plus 40, 19 plus 21, which will become 40. Similarly for next frequency is added, that is 40 plus 29, that will become 69, and that addition is continue up to last class interval. So the highest cumulative frequency for less than type will be 515, which is equals to total frequency. Similarly for greater than type, we start from last class interval. So the frequency of last class interval and greater than type cumulative frequencies will be equal. Then we add upwards one by one, that is 21, then 21 plus 26, that will become 47, then 47 plus 27, that will become 74, and so on up to first class interval. Now how these cumulative frequencies are interpreted? So less than type cumulative frequency is 318. That means there are 318 individuals in the sample whose monthly income is less than 1150 rupees. Similarly, greater than cumulative frequency, if its value is suppose 364, then there are 364 individuals whose monthly income is more than 1050. The left hand side values of class interval are called as lower limit and right hand side values are called as upper limit. So less than cumulative frequencies are interpreted with respect to upper limits and greater than type with respect to lower limits. Same thing is performed in while plotting the ogives. That is 90 is plotted against 850, 40 will be plotted against 900, that is upper limit of the class interval, and greater than type cumulative frequency, that is 515 will be plotted against 800, 496 will be plotted against 850, and so on. So here, while plotting the cumulative frequency curve, class intervals are taken on the horizontal axis and cumulative frequencies are taken on the vertical axis. Then plots are made in such manner and in such manner. This plot is for less than type cumulative frequency, so it is called as less than type cumulative frequency curve, and red line is shows the more than type cumulative frequency curve. Here you can see that less than type cumulative frequency curve stop 1 point after the greater than type cumulative frequency curve. If these two ogives intersect at a particular point, from this point we draw a perpendicular on the x-axis or horizontal axis, then where it intersects to the horizontal axis, it will give median. That is, from this point, if we draw a vertical line, then this point will give the median of the data set. So it was about the cumulative frequency curve. Now, measures of central tendency. So third method for representing the data was using a summary measures, use of summary measures. So what are the summary measures? Summary measures are used to represent the data. In this method, data is represented with the help of four different quantities which are called as summary measures. These summary measures are measures of central tendency, measures of dispersion, measures of skewness, and measure of kurtosis. In today's lecture, I will discuss about measures of central tendency only. So what is the central tendency and what are its measures? Every dataset has a property to tend towards a central point if sample size is increases indefinitely. The property, this property of data called as central tendency, and the point towards data tends is called as measure of central tendency. In other words, we can say that the measures of central tendency are the central point of the data towards which the data tends or around which data is scattered or concentrated. That is the central point of the data around which data is scattered or data is concentrated. The main measures of central tendency are arithmetic mean, median, mode, geometric mean, and harmonic mean. Basically, first three measures are used generally. Geometric and harmonic mean are considered in some special cases only. Now, arithmetic mean. Arithmetic mean is the simplest measure of central tendency. It is also called as mean or average. It can be defined as a sum of all the observations divided by the number of the observations. That is, it can be obtained by the formula x bar is equals to summation I goes 1 to n xi upon n, where xi is observation, n is the number of observation, and this sign represents the sum of all the observations, or you can say total of all the observations. That is summation I goes 1 to n. If data is arranged in the form of frequency table for discrete data or for class interval data, then mean can be obtained by using formula x bar is equals to summation fi xi divided by summation fi. Summation fi is called as total frequency, where xi is value of observation for discrete data, or it is called as class mark for the class interval data. Fi is the frequency of ith observation in case of discrete data, and it is the frequency of ith class interval in case of class interval data. There is another method which is easier than the previous one for calculating the mean of the frequency tables, which is also called as shortcut method or step deviation method. In this method, mean is given by x bar is equals to a plus summation fi di upon summation fi into h, where a is called as assumed mean, di is called as deviation of the observation from assumed mean, given by di equals to xi minus a upon h. H is called as width of class interval. Summation fi can also be written as capital N, which is also called as total frequency or total number of observation. Properties of arithmetic mean. If there are two groups, group 1 and group 2, having mean x1 bar and x2 bar and number of observations n1 and n2 respectively. If these do these two groups are combined, then the mean of combined group will be given by x bar is equals to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Without seeing one or two or all the observations in both the groups, if mean and count and size of groups are available, then we can obtain easily the mean of combined group using this formula. The formula can be extended for k groups and it will become x bar is equals to n1 x1 bar plus n2 x2 bar plus so on nk xk bar divided by n1 plus n2 so on n plus nk. If x bar is, second property is if x bar is mean of n observations and each observation is multiplied by a constant c, then the mean of new observations will be c into x bar, that is mean will also be multiplied with that constant. Similarly, if x bar is mean of n observations and a constant c is added to all the observations, then the mean of new series will become x bar plus c. In general, property 2 and 3 can be called as the mean is affected by the change of origin and change of scale. The multiplication or division of observation, all the observations by some constant is called as change of scale, and addition or subtraction of some constant from all the observations is called as change of origin. Fourth property is sum of the deviation of all the observations from their mean is 0. That is summation I goes 1 to n xi minus x bar is equals to 0. If all the observations are constant, that is represents only single point, that is if we have 10 observations and value of each observation is 5, then mean will also equal to observation and it will also be 5. Each measure of central tendency has some merits and some demerits. So in case of mean, there are demerits larger than the merits. The merits of arithmetic mean are it is rigidly defined, it is easy to calculate and easy to understand. It is based upon all the observations and it is suitable for further mathematical and statistical calculations. The demerits of means are that it cannot be calculated by inspection or by graph. It cannot be calculated for the qualitative data. If class intervals are open-ended, then mean cannot be calculated. Open-ended means if lower limit or upper limit of class intervals are missing. Generally, upper limit are missing, then mean cannot be calculated. In some situation, lower limit can be taken as 0. If we talk about wages, we talk about age, we talk about income, then the lower limit of class interval is missing for first class interval, then it can be taken as 0. But if upper limit of last class interval is missing, then we can never calculate the mean. It cannot be assumed arbitrarily. Mean cannot be calculated if one or more observations are missing. Mean is highly affected by the extreme value. That is the values which are very much higher or very much lower as compared to other observations. The values which are very high or very small as compared to other observations are called as extreme value. However, demerits are the number of demerits are larger than the number of merits for arithmetic mean, but it is preferable among all the measures of central tendency due to last two merits that it is based upon all the observations and it is suitable for mathematical and statistical calculations. Due to these properties, arithmetic mean is preferable over other measures. Second measure of central tendency is median. Median it can be calculated for both qualitative as well as quantitative data. It is the middle value of all the observations. That is the point which lie exactly in the middle of the data set is called as median. Provided the data set is arranged in the either descending order or in the ascending order. If data is in raw format, then median can be obtained by using the formula median is equals to value of n plus 1 by 2th term. If n, that is number of observations, is odd, and it will be obtained by using the formula median is equals to value of n plus 1 by n by 2th term plus value of n by 2 plus 1th term divided by 2 if n is even. If data is discrete, then the median of the observations having cumulative frequency just greater than capital N upon 2, that is total frequency divided by 2. If data is arranged in the form of class interval, then median is obtained with the help of this formula. Median is equals to L naught plus N by 2 minus C divided by F naught into H, where L naught is lower limit of the median class. F naught is frequency of median class. C is the cumulative frequency before the median class. N is total frequency and H is width of median class. Now merit and demerits of the median. Median is rigidly defined. It is best measure for qualitative data. It can be calculated for qualitative as well as quantitative data. It is not affected by extreme values. It can be calculated for open-ended class interval. It can be easily obtained with the help of graph. As I have told with cumulative frequency curve that intersection of, if we draw the perpendicular on horizontal axis from the intersection of two ogives, then it will provide the median. The demerit of median is that loss of information at it is based upon single observation only. It shows only the middle observations. It not consider the observ other observations for the calculation. It is not suitable for further mathematical or statistical calculations. Next is mode. Mode can also be calculated for qualitative as well as quantitative data. It is the term which have highest frequency in the data. That is the value which occur maximum number of times in the data is called as mode. For raw data, it is the value of observation having highest frequency. If data is arranged in the form of class intervals, then mode can be obtained by using formula mode is equals to L naught plus F naught minus F minus 1 divided by 2 times F naught minus F minus 1 minus F1 into H, where L naught is lower limit of mode class, F naught is frequency of mode class, F minus 1 is the frequency before mode class, F1 is frequency after mode class, and H is the width of class interval. If two values occur same number of time and which is maximum, then data is called as bimodal. And if more than two values occur maximum number of times, then data is called as multimodal. Merit and demerits of mode. Mode is rigidly defined. It is a good measure of qualitative data. It can be calculated for qualitative as well as quantitative data. It is not affected by the extreme values. It can be calculated for open-ended class interval and it can be easily obtained with the help of graph. The mode can be obtained with the help of histogram. The demerits of mode. First demerit is loss of information at it considered only single observation for the calculation. Does not consider other class interval other than mode class, or it cannot take into consideration the other observations if data is in the raw format. It is not suitable for further mathematical or statistical calculation. Mode cannot be calculated if the highest frequency occur for the last class interval. Mode cannot be calculated if the observations occur same number of all the observations occur same number of time. That is, for case of multimodal data, we cannot decide which observation is mode. There is a approximate relationship between mean median mode, which is given by this formula: x bar minus mode, that is mean minus mode, equals to 3 times mean minus median, or mode is equals to 3 times median minus 2 times of mean. If mean and median are available, sorry, any two quantities among these three mean, median, modes are available, we can obtain third one. But if data is available, then we have to calculate it from the data. If data is not available, then we have to go for these formula, as these are approximate relationship, not the exact relationship. So how we calculate these quantities, it will be discussed with the help of some examples. First example is for raw data set on 34 patients, which shows arterial activast partial thromboplastin time for 35 patients, which is given in the following table. Then for calculation of mean, we add these quantities, that is 20.7 plus 29.3 plus 34.4 plus 56.56 up to last value 50.1. And sum of these observations will be 1187. The number of observations is 35. So mean can be obtained by dividing sum of observations, that is 1187 divided by the number of observations, that is 35. That is mean is equals to 1187 upon 35, which will be equals to 33.91. That is, we can say that average time for average thromboplastin time is 33.91 units. For calculating the median, all the observations are arranged in the ascending order, that is 20.3, then 20.7, 20.9, and so on up to maximum observation, that is 56.6. Here 35 observations are available, so we use formula which is for odd number of observations, that is value of n plus 1 by 2 at term. N is 35, so median will be value of 35 plus 1 by 2 at term, that is value of 36 by 2 at term. 36 upon 2, that will become 18, so median will be the value of 18 term. So here we can count 1 2 3 4 5 6 7 7 14 15 16 17 18. That is 18th term is 31.20. So the median of the data set is 31.20 units. For the calculation of mode, we check the number of times a particular value occur. 20.3 occur one time, 20.7 occur one time, similarly 22.5 occur two times. Then we move forward, 22.8 occur two times, then 24.9, 28.4, then so on. Then we move forward, each values occurs one times, then 46.1 occurs three times, then remaining value also occurs one time only, so maximum number of times occur 46.1. So we said that the mode of the given data set is 46.1. So it is how we calculate the mean for raw format. If data is arranged in the form of class interval table, then how we calculate? For that, I have taken this example in which wages of different factory workers are considered. Wages are in the form of class interval, that is 170 to 180 rupees, 180 to 190 rupees, and so on up to 240 to 250 rupees. And here in second column number of workers are represented. Now for computation of mean, first we calculate the class mark, which is obtained by formula xi is equals to upper limit plus lower limit divided by 2. Then we construct the following table, that is wages, number of workers, which are also given in the previous table, then class mark will be lower limit plus upper limit upon 2. That will for first class it will be 175, for second class it will be 185, and so on. For last class it will be 245. Then we multiply the number of workers with the class marks, that is fi into xi. It will give these quantities. Then we add this fi xi, all the FIXI, then we will obtain this quantity, that is 1,23,350. The total number of workers is 590. Then mean will be obtained dividing by summation of FIXI by summation FI, that is 1,23,350 by 590, which will give a quantity 209.07. But these multiplication will become quite difficult if we perform these multiplications manually. In that situation, we prefer the method of step deviation. In step deviation method, we take some particular value as assumed mean. Generally, the class mark for middle class interval is taken as assumed mean. In our case, we have 8 number of class intervals, so either fourth or fifth can be taken as assumed mean. So I have taken 205 as assumed mean. Then we calculate the deviation di, obtained by formula di equals to xi minus a upon h, that is class mark minus assumed mean divided by width of class interval. Then we construct the table again. Here you can see after xi the column of di is added, that it is obtained by 175 minus 205 divided by 10, that is minus 30 divided by 10, which will give minus 3. So these values will become minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So in such manner the multiplication will become much easier. We multiply fi into di, it will give fi di. Then sum these fidis, it will give 240. Then mean can be obtained by putting into the formula a plus summation fidi divided by fi in divided by summation fi into h, that is 205 plus 240 divided by 590 into width of class interval, that is 10, that is 205 plus 4.07, which will give 209.07. So you can see that mean obtained by these two methods are similar. For obtaining the median, first we calculate the total frequency divided by 2, which will be 590 upon 2, that will give 295, and calculate less than type cumulative frequency. Here we can see for this class interval cumulative frequency is just greater than 295, and before it is smaller than 295. So this class is taken as median class. So L naught will become 200, F naught will be 92, C will be 205. That is frequency, cumulative frequency before median class. Now we put these values into the formula, then median will be obtained as 209.78. So the most important thing for computation of median is decision about median class. That is the class interval before which cumulative frequency is less than n by 2, and for the class it is just greater than n by 2 will be called as median class. For the calculation of mode, we the most important thing is decision about the mode class. So the class interval having highest frequency is called as mode class. So from this example we can see that the maximum frequency is 220 to 200 is 100 for class interval 220 to 230. So this class is taken as mode class. So for mode, 220 will become L naught, F naught will be 100, F minus 1 will be frequency before mode class, that will be 95, and F1, that is frequency after mode class, which will become 75. Now we put these values into the formula, that is F mode is equals to L naught plus F naught minus F minus 1 divided by 2 times F naught minus F minus 1 minus F1 into H. Then putting into the formula, the mode is obtained as 221.43. So it is how we calculate the measure of central tendency for raw data as well as for class interval. So it was about today's lecture.